Okay, our project is about running complex simulations on BIM models. So we are a team of researchers from Advanced Real-Time Simulation Lab, and I just want to talk about our team members. So we have like 4 different sections. We have a special team that works just on data extraction from the BIM model. And then we had a visualization team that worked on visualization separately. And we also had few mentors on Cadmium tools. And then we had Tiago and Danish on BIM models and business insights. So one of our main goals, so this is our big picture, because we're going to show you what we implemented, which is a small part of the big picture. So one of the big picture is we have large BIM models of Carleton University campus, and we are planning to make a digital twin of it. And one of the issues that we were having is extracting the BIM data and then adding a real-time simulation information to it. So that became a target. So our goal became like, how can we extract the BIM data into a text that goes into a simulator and back to the BIM model for visualization, because we wanted to visualize real-time simulations for building performance and to understand energy performance or even pedestrian models and other things. So we have a simulator, Cadmium simulator, and this simulator already has pre-built models that can run carbon dioxide level, or this is more studying about pandemic distribution in the supermarket. So with all these models, I was thinking like, what if architects or designers are able to access it, right? Because it's already a built-in repository. And then on the other hand, our simulators were not having a good contextual visualization. It was more on a 2D base. So this hackathon opened up a lot of options because when I was just looking at this post on LinkedIn, I was thinking like, why not we can try it, and decided to attend Autodesk Forge workshop, and we came up with the model after attending this workshop. So I'm going to say why we choose Autodesk Forge. So one of the idea that I was talking was Autodesk Forge. So I'm kind of an intermediator between our simulators and our architect groups in our lab. And I often found this difficult where I have to teach the back-end enders how to use Revit model, right? So that means like I have to teach them each of them how to access it. On the other end, architects, well, few have more programming knowledges, but there are a few who do not have programming knowledges. So we want to make it easier for them to access Cadmium or simulation tools where they don't have to do complex programming, but they can simply define, okay, I want to see the CO2 levels in the room, or if I want to see the airborne spread inside the building, they can just choose the model and then it pushes out the data, and then we run the simulation at the back end and visualize it. So the whole idea was to automate it, but that's not the scope of this hackathon. So our idea just became like, we tie the Revit models, it extracts the data, then we manually run the simulation outside and push the data back to the visualization in the BIM models. So that was our focus there. And what was the current state of the model? So currently Cadmium was using either text-based or image-based, and that's where it extracted the data. So we would just send a screenshot of the plan and it would run the simulation based on it. But it was not taking exact locations or XYZ positions of it. So we wanted to figure out a way to extract the elements, wall space, those positions or zones, rooms, or even building massing, because for example, pandemic models is run for a whole city, right? In that case, we don't need details of the building, but we want a larger scale. So these were the steps that we wanted to implement and try it. So we started this. This was a challenge for us, and everything was started during the hackathon time. And Griffin, Kevin, Thomas, and Cypher involved it. And I'm going to let Griffin explain the process on what we did.
Okay, can you guys hear me?
Mm-hmm.
Good. So the data extraction starts with the viewer. We have, if you see in the bottom right, we have the CO2 button there. That when you click it, it sends the ID of the model over to the server, and and you download that. Start at the beginning. Initially, we did all of the work in the viewer, and the viewer created an image that you see on the bottom right, which is a reasonable floor plan for that building, and everything worked just fine. It was based on bounding boxes. It worked very quickly, but unfortunately, bounding boxes don't always work, especially when you have curved or slanted walls. And so we couldn't operate on that. We needed to get access to the raw geometry data. And for that, we needed to work, well, after a few tries, we landed on using Autodesk's derivatives API. And so the process is now take the model that we care about, go and get the file manifest, go and find the database for all of the properties, work out what IDs belong to things that are walls or things that are doors or windows or whatever other elements we care about for the purposes of the simulation. And then we send out derivative job requests to Autodesk's servers asking for OBJ files. And once those are finished, we download them, open them up. An OBJ file is basically just a list of triangles in 3D space for our purposes. So we look through all of those triangles, and any triangle that intersects with a simulation cell, well, sets that cell to be that triangle's type. With some extra rules where if a cell is both a door and a wall, then we're going to call it a door because that's more important. And the result of that is a fairly accurate, though a bit granular, 3D representation of the space at hand. And we plugged that into our simulator and hit go about 98.5 hours ago, and it's still running. Our simulator needs some work. And so we have added in a semi-automatic process of flattening that 3D model down into a 2D model that can be run in about 5 minutes instead, because that's far more practical for our purposes. And the results of that you can see on the further slides. I think that just about covers extraction. Vinu, if you want to take back over.
Thank you, Griffin. So the extraction was a little bit harder for us, and translating as well, because initially we tried it for a small house and it was fairly straightforward. But then when we started taking in a large model like an office plan, which comes up with a massive detail, then how we define in Revit model also started playing a role. Also because like curtain wall comes as wall, and then wall comes as wall, and then we have to differentiate those things as well while we were extracting the data. And yeah, we had to show and highlight what were the vents and everything clearly to our developers, so they were able to identify the nodes and everything and extract that information. So the complexity increased with the size of the model. So on the other hand, we had data visualization. And in this case, we just wanted to map whatever data output that we got from the Cadmium simulator back into the BIM models. So because this Cadmium simulator doesn't only show carbon dioxide level, which we have used as an example for this project demonstration, but also it does evacuation models. So we wanted to have objects or elements to be tied to the information, so it can be moving around or represent the information. So initially, so we tried with Autodesk Forge example point clouds, and this has been our direction from where we derive with a lot of our solutions. So that was a base file, and this was a first step that we actually did with data visualization. This is for the small house, which we did. We were successfully able to tie the information back in. So again, you can see how when the data reads, these are all like walls, and we had to eliminate those details out when we inputted the data. And also we had issues initially if the project point is not, base point is not defined properly, or the location is not designed properly, then the alignment would not happen properly. So those things we had to manipulate it. But this is our final product. Our final product looks easier, which is what our core idea was, is if the designers has one click, so this is the icons we built here. They click on the CO2 model. Okay, and you can see the Cadmium JSON file is generated. So again, in this, the data extraction can happen for any type, but we have fine-tuned it for our simulator. But maybe with some code changes, it can be applicable overall for others as well. They can simply just click on it and the information will be downloaded. I'm just playing it in again, since it's a short video. And this was one of our idea because we want to make this very simple for people who don't understand programming, and they can just access this interface and it does the work for them. On the other hand, this is our data visualization. So you can click on the animation and it simulates the CO2 level. Okay. Yeah, so what I want to conclude is, that's it. One of the things that I want to conclude is this is a beginning for us because we are looking at a much larger projects to work on, and just getting this loophole connection was a big step for us, and then we are looking to tie more data back into the simulation. So if you have any questions, we could answer on that.